So with polynomials, solving a polynomial equation by graphing, I hope that at this point in time when we talk about a polynomial, we talk about a solution, solving a solution, we remember that there's four things that we associate: solutions, zeros, the x-intercepts, and then last but not least, roots. All four terms are meant to indicate really the same location on a graph. So when we talk about solutions, if x-intercepts are my solutions are the same thing, then we typically can start identifying by looking at a graph where it crosses over the x-axis. So today's goal, we're going to solve some polynomial equations by graphing. And really, we've been doing these kind of things, but we're going to focus on just greater than quadratic equations that we're working on. So looking at this image, solving a quadratic equation by graphing, here is the equation. And then it tells us, and we've worked with this, a related function is found by rewriting the equation with 0 on one side. So I'm going to, in this case, I need to subtract x and subtract 6 from both sides. And when I do that, I come up with f of x is equal to x cubed plus 2x squared minus 5x minus 6. And then thinking about when we make it equal to 0, this related function, I now know that as I cross over the x-axis, these are going to be my zeros and my x-intercepts, which are in turn my solutions and roots. So that is thinking through what we're doing and trying to, practice, just conceptually understanding. I mean, at this point in time, when we look at this, you should be able to look at this graph and say, hey, it's a cubic graph. I know that the coefficient is positive because my general slope is positive. You should know that this is a relative maximum. This is a relative minimum. We're just expanding on the characteristics we've already learned about. So solving this equation by graphing, in this example, they want us to create this related function. So we have x to the fourth plus 3x squared minus 5 is equal to negative 4x cubed. I need to get that over to the other side so I can be equal to 0. So I take this negative and I add to make this equal to 0. So I add 4x cubed to both sides. So now I have that related function that I can graph and come up with my zeros. So when you put that into y1, and then we turn around and look at the graph, this is what my graph looks like. And finding the zeros, let's see, if we have it right here, if we press, y equals, and we input the function, and then we press second button, calculate 2. And what that does is that allows us to calculate the zeros. So when once I have this graph and I hit second calculate, that allows me, and then the 2, it's the option to calculate zeros. So it's asking you, it's saying, which 0 do you want to calculate? And it says left boundary. Okay, we have 2 zeros in this graph, so it doesn't know which one you want to calculate. So it says left boundary. So it's saying go to the left side of the 0 that you want to calculate. So you just arrow up to where your cursor is on the function to the left of the 0. And then when you hit enter, it says give you a right boundary. So you just go to the right of the function where it crosses over the x-axis. And then it says guess. You just arrow back and hit enter, and it's going to give you the decimal at the bottom of the screen. So when you hit, it'll tell you your 0 is negative 3.217748, because this was the 0. So when you go to do that same process again, it'll say left boundary. You come over here a little bit left of your x-intercept, then you hit enter and you go a little bit right of your intercept, and then you hit enter and you come back and it will give you your second y-intercept, or x-intercept, sorry. So this is what it looks like, and it's right there, and you just, answer the question accordingly. So it says all zeros, so it looks like we've rounded to the 100th place. So letting the calculator do the function for us. So we can do the same thing here. Take a minute, do your related graph, your related function, so you can graph it, and then put it into the graphing calculator and see what your answers are. And then, hey, start the video again and see if it's correct, or see if we have the same answers. I could be wrong. So when I do my related function, I came up with negative 1/2 x to the 4th plus 4x squared plus x minus 1 equals 0. When I put into the graphing calculator, this is what my graph looks like, and I can see that there are actually 4 roots. 1, 2, 3, 4. So I have to calculate 4 solutions. So looking at that, so as we go through the process, what answers have you come up with? And it does ask us to round to the nearest 100th. So when I repeat that process, this process to find out what my zeros are, doing the left boundary, the right boundary, I'm able to come up with, let's see here, I have negative 2.64, I have negative 0.66, I have 0.39, and I have 2.91. And I'm able to come up with those zeros, letting the calculator do the work for me. So with that, just being able to understand, again, the relation of the x-intercept is my solution, and being able to calculate that point. Here, now, they've done a lot of the work for me, but let's see, how did they come up with it? For an exhibit of 6 or fewer emperor penguins, the pool must have a depth of at least 4 feet, a volume of at least 1,620 gallons, or 217 feet cubed per bird. Okay. Now, if a zoo has 5 emperor penguins, what should the dimensions of the pool shown at the right be to meet the minimum requirements? Well, so they said the volume, remember your volume is going to be length times width times height. So I would take and I would multiply 2x times 2x plus 3 times 5x minus 2, and that would give me my polynomial, which represented the volume. Okay, and I know then that the volume should equal well, if I have 5 penguins, right, the volume should equal 5. They told me I needed 217 cubic feet per penguin, and if I have 5 penguins, I would multiply 5 times 217, and that would give me that 1,085. Okay, there's my formula. There's my polynomial. There's what the polynomial should equal. So how do I figure out what in the heck x is? How about if I just do some inverse operations and create that related function? I will tell you, looking at this example, they wasted a lot of time. Okay, we're going to put this in the calculator. I do not need to distribute. I am making errors if I work this out and distribute. But what I do need to do is I need to move this over to the other side to create the related function. Now what I can do is I can take 2x and I can just put this straight into the calculator just like this. I do not need to multiply it out. That, and I can say equals 0, and put this into the calculator, and I am going to get the same answer that they got when it came to my solution. So let's see here. So when I graph my related function, this is what it looks like on the standard screen. And to do some form of interpretation, I'm going to assume that this is my solution, and it looks like 1, 2, 3, a little bit over 3. So somewhere between x equals 3 to x equals 4. So let's see what they have. And I guess I really don't care what they have right now. Let's just looking at my intersection and doing the related function and finding the 0. When I found the 0, it told me my 0 was 3.5, which I'm going to tell you is the answer that they came up with, 3.5. How could I determine that? What did they do? Well, they made a system of equations. They took one side of the equation and made it equal to the other side, and then graphed them both on y1 and y2. But again, we didn't need to multiply that out. You can definitely do this method, but I'm going to not waste my time with that multiplication. I'm just going to say, hey, in y1, I'm going to input 2x plus 3, and then 5x minus 2. And then in y2, I'm going to input 1085 and then allow the calculator to do the work for me. I'm making a lot of errors at this point in time. If I multiply that out, I could have one of the digits wrong and get it wrong, but it will graph the equation in factored form like that. Now, when they calculated the intersection point, they did have x is 3.5, which is your solution. So keep that in mind. And then how do you figure out your length? Well, you just substitute in, length is 2 times 3.5 plus 3. Width is 3 times 3.5 minus 2. The depth is 2 times 3.5. So that's how we were able to calculate those, the dimensions that we would need in order for it to be accurate, which, I think it's something pretty simple in the end. But there you go. We would meet our humanitarian requirements to make sure that those penguins had the proper living space if we were to make sure that these were the dimensions. If we added a 6th penguin, we're going to have to make it bigger. If we took one of the penguins away, hey, they're going to be living large in a really spacious apartment. Okay, so just thinking about how can we input and do these solutions, letting the calculator do the work for us, and then we'll get some practice in this in time. And I'll tell you that the very basics that you need to be able to do is write out, what is my related function, right? If that's what I'm putting into the graphing calculator, let's see it. If I'm using a system, what system did you put in the graphing calculator? So there we go. And without further ado,